So today we are quickly going to build an impressive application which delivers the real-time response using AI agent as backbone and LangChain as the framework. The LangChain is the Python framework which is used to craft an efficient generative AI application specifically for the business use cases. And the mastermind behind this AI agent is nothing but AI models, large language models, which enables this application to generate the intelligent responses. So there are numerous LLM models available in different platforms like Hugging Face, ranging from small to large. It depending upon its size, we can download some of the small models to our system. It depends upon the configuration of our system. For instance, in my system, it's 8 GB GPU, so up to 8 billion 7 to 8 billion parameter models I can download. So if I try to download the large models, it will cause the memory error. However, in order to get the efficient result, we need to use large efficient models like 70 billion parameters, which I'm going to use this project. So in order to connect with this model, it's better to use via API. So that's why I'm going to use another platform called Grok, which is highly efficient and which enables the model to connect via API seamlessly. So Grok is an open source platform where you can see wide variety of models inside this documentation. See, from small to large models are available here. 8 billion parameters, even 405 billion parameters is available. So here we are going to use this 70 billion Llama 3.1 versatile model. One thing I want to tell you guys that I will only focus on the open source services. I'm not going to prefer any paid services in future. In my future videos also, I'm not going to prefer, and I'm only aiming to minimize this use of the external applications and services, as we can build the components, most of the components or the services by ourselves, to reduce these type of dependencies. So Grok, being open source, allows us to directly connect to the models using the API keys. Here you can easily create the API keys and from this platform, and with it we can connect to this desired model efficiently. So here in this code you can see that I'm using the chat Grok service from LangChain Grok library, which enables the seamless integration of Grok service with LangChain. So here I'm initializing the chat Grok model. This is the model name, and this is API key, which is used for the authentication purpose. And we can see another important parameter called temperature, and basically this temperature which controls how creative or random the AI response will be. By setting this temperature to a very low value like this, we ensure that the response are more factual and precise. See this snippet, I am trying to invoke the model with asking a question, explain about generative AI. See, the result is pretty much good. And however, when I trying to ask another question, this is pretty much a real time question. Today's petrol price in Bangalore. So in this question, we are expecting some real time answer. Let's check how the content is. Here I am not able to provide the real time information. So here it indicates that the model is not capable of handling the real time cases. So in this project, we are enabling our model to work with these type of real time questions. Okay, so to achieve this, we have integrating these LLM models with Google API using AI agents. So you might be wondering that why I am using this buffer memory here. So if you have been used some chat models, and you might be noticed that some of the models will forget what you have said after each message. It's feel like you are talking to somebody having zero memory. Actually, that not to be happen. In order to address this, we use buffer memory. It enables the model to maintain a running memory which stores our previous chat interactions with the model. And this way, when we are trying to ask something like follow-up questions, then it will recall the context of the previous interactions and respond accordingly. So our chatbot is not just pulling the answers out of thin air. It's smart enough to know when it needs to search Google or check Wikipedia to provide the most up-to-date and reliable information. So these are the tools in LangChain, and here is how we set them up. We are using two tools, one for Wikipedia and the other for Google search. In the Wikipedia tool, the code instructs the bot to retrieve the most relevant article and display up to 500 characters of it. The second tool is Google search, where we use the Google search API wrapper, where the bot needs the real-time information like what is today's petrol price and what are the movies playing nearby. It performs the Google search, and it like telling the bot, hey, go check Google and let me know what's trending. That's why we use this Google search API wrapper along with the tool from LangChain. So we provide the tool's name and description and a function that uses the search wrapper whenever we ask a relevant question. So before that, we need to initialize this Google search API with Google API key and search engine ID. I will tell from where will we get these details. In order to get the Google search API key, first go to the Google search and search for Google search API key, and it will displays the google support.com, and we just click here, and here there is a link for the API console. Just click here, and from here we can create the credentials. By clicking the credentials, you can create easily the API key. In order to get the search engine ID, just search for search engine ID. It will show this link, programmable search engine ID. Just click here, and here you can directly go to the search engines. Here in this platform, I have already created the Google search, and otherwise you can add a new one from here. And here in clicking the Google search, you will get the search engine ID from here. This is our search engine ID. Next up is the prompt template. This template is designed to help the AI agent generate thoughtful responses by making use of available tools and the chat history. Let's break it down step by step. First, we have the input variables. These are the variables passed into the template to customize the prompt. The AI agent uses the chat history, which, as we have already talked about, is simply the memory of the previous conversation. Next is the agent's scratchpad. This is like the agent's intermediate thoughts or reasoning during decision making. Then we have the input, which is the current question or input from the user. Now we come to the tool names, which are the list of tools the agent can choose from. These are the tools we have already set up. Then there is the tools themselves, the detailed description of how each tool works. After that, there is metadata, which contains information about the prompt, source, and version control, etc. Next is a template. This is the main structure that the agent follows. It lays out clear guidelines for how the agent should think, act, and respond. Here is how it works. It starts with defining the AI as an intelligent assistant. The AI is instructed to act like a knowledgeable assistant that uses the tools effectively. The agent has access to both tools and the chat history, which help it provide contextually relevant responses. The format of the response is simple. It starts with the input question from the user. The AI then reflects on the question, considers the chat history, and decides which tool to use. Next, the agent takes the action, choosing one of the tools to perform the task. The action input is a specific query passed into the tool. Then we have the observation, which is a result or output from the tool's action. This cycle of thinking, acting, and observing can repeat as many times as needed until the AI has enough information. Finally, the AI provides its well informed response to the original question. The template wraps up with the word begin, prompting the AI to start processing the input according to the instructions. Now that we have our AI brain, memory, and tool setup, it's time to bring it together. We create an agent to control everything. So, what's an agent? Think of agent like the conductor of an orchestra. It decides when to use the LLM, when to run the Google search, and when to check Wikipedia. It makes sure everything works smoothly together. This is where we create the agent using the create react agent function, which we have imported from LangChain.agents. The function takes four arguments: LLM, tools, prompt, and stop sequence. The create react agent ensures the agent knows when to use each resource. The stop sequence is used to instruct the agent when to stop generating text, making sure it doesn't go on indefinitely. Next, we want to create the agent executor. This line create an instance of the agent executor class which is responsible for executing the agent that you have created. The executor manages how the agent interact with the tools, memory, and handle errors. Finally, with our setup complete, we can now ask the bot real-time questions. Here we have the agent executor which we can invoke by passing a dictionary. The key is input and the value is the question we want to ask. So first I asked what is the today's petrol price in Bangalore, and the bot currently respond today's petrol price in Bangalore as of 14th October 2024, that is today, is 103.57 per liter. That was accurate. Next I asked a follow-up question. List out the movies running in the same place. Notice that I used same place instead of Bangalore, which makes it a follow-up question. The AI provided a list of movies currently running in the theater in Bangalore based on the available information. The key here is that I only mentioned same place, not Bangalore. Yet the bot understood that same place referred to Bangalore because it remembered my previous question. This is a power of buffer memory that we have already created, integrated with the agent. It keeps track of the conversation context, allowing for smooth follow-ups. I use the same logic to build the application I just showed you. Along with this video, I will provide the GitHub link to the notebook. In the next video, I will be adding the another agent for retrieval augmented generation. After that, I will share the application code within the next video. Thank you. Bye bye.